Hello viewers, my name is Edwin Chen and this is my grade 12 Advanced Functions CCT. Today I'll give you a step-by-step tutorial of an assigned question from the grade 12 Nelson Advanced Functions textbook. By doing so, you'll gain a better understanding of course content and will receive a special step-by-step explanation of a sample problem. The question I will be demonstrating is on page 308, number 3. It is a communication question where I will thoroughly explain how to complete this question step by step. The question states, for each function, determine the equations of any vertical asymptotes, the locations of any holes, and the existence of any horizontal or oblique asymptotes. Based on reading this question, we know that this is material from Unit 3, Graphing Rational Functions. In question 3c, it says y is equal to 3x plus 33 over negative 4x squared minus 42x plus 22. This is a rational function. We can tell because there are two polynomials, one in the numerator and one in the denominator. The question states y is equal to 3x plus 33 over negative 4x squared minus 42x plus 22. The first step into solving this question is factoring. We can see that we can common factor both the numerator and the denominator. In the numerator, 3 is a factor of both 3x plus 33, so the numerator would be 3 bracket x plus 11. In the denominator, we can see negative 2 is a factor of all three terms. The denominator would look like negative 2 bracket 2x squared plus 21x minus 11. Next, after common factoring, we can see that there is a complex trinomial in the denominator. We must continue factoring until we can factor no further. After we have factored the complex trinomial in the denominator, it would look like negative 2 bracket x plus 11 bracket 2x minus 1. If we refer back to the question, this says that we must find the locations of any holes. And in order to do that, we must look at the numerator and the denominator. If there is anything similar in both the numerator and the denominator, we know that there is a pinhole. And from our equation, we can see that x plus 11 appears in both. In order to find the x-coordinate of the pinhole, you must make the similarity that you found equal to 0. By doing so, we find the roots of the pinhole. If we do that for this equation, we get x plus 11 is equal to 0. By isolating for x, we get x is equal to negative 11. Therefore, we know the x-coordinate of the pinhole is that x is equal to negative 11. After we have found the x-coordinate of the pinhole, we must simplify the equation. We must simplify the equation by taking out x plus 11 in both the numerator and the denominator. The new equation will be y is equal to 3 over negative 2 x minus 1. This is a new equation that you'll be using for the rest of the question. Now that you have a new equation without the pinhole, we must find the y-coordinate of the pinhole. To do that, we must substitute negative 11 for x. Therefore, the equation is y is equal to 3 over negative 2 bracket 2 times negative 11 minus 1. 2 times negative 11 is negative 22. Negative 22 minus 1 is negative 23. Negative 23 times negative 2 is 46. Therefore, our equation is y is equal to 3 over 46. Or 0.0625. You can use either because we are not graphing, so a decimal or a fraction answer is fine. Now that we have both the x and y coordinate of the pinhole, we know that the pinhole is at negative 11 and 0.0625. We can now check off that we have determined the equations of any holes. The next part of the problem is to find the vertical asymptotes. In order to do so, we must find the roots of the denominator so that we can find the asymptote. Therefore, it will be negative 2 bracket 2x minus 1 is equal to 0. From previous years, you know that you must expand the brackets. Negative 2 times 2x is negative 4x. Negative 2 times negative 1 is plus 2. Therefore, we have negative 4x plus 2 equal to 0. You must isolate for x, so negative 4x is equal to negative 2. Divide both sides by negative 4. Therefore, you get x is equal to 0.5 or 1 over 2. Therefore, we can now check off that we have determined the equations of any vertical asymptotes. The final part of the question states that we must find the existence of any horizontal or oblique asymptotes. To do this, we must compare the degrees of the numerator versus the degrees of the denominator. In grade 12, we have learned that if the numerator has a lower degree than the denominator, there is a horizontal asymptote at y equals 0. If there is the same degree, the horizontal asymptote is that y is equal to the a of the numerator over a of the denominator, where a would be the leading coefficient of each numerator and the denominator. Finally, we know that if there is a higher degree in the numerator, there is an oblique asymptote where we must use long division to find the answer. Going back to our equation, y is equal to 3 over negative 2, 2x minus 1, we know that the numerator has a lower degree than the denominator because there is no x values in the numerator, while there is a degree of 1 with an x in the denominator. Therefore, we know that there is a horizontal asymptote at y equals 0. Finally, if we put everything together, we know that there is a pinhole at negative 11 and 0.0625, a vertical asymptote at x equals 0.5, and a horizontal asymptote at y equals 0. To check our answer, we can use Desmos. If we plug our equation into the program, we can see that there is a pinhole at negative 11 and 0.0625. There's a vertical asymptote at x equals 0.5, and there's a horizontal asymptote at y equals 0. In review, the first step is finding pinholes. In order to find a pinhole, you must look for anything similar in the numerator and the denominator. If there's anything similar, you must simplify the equation further so that you can eliminate the pinholes from the equation. Next, you must find the y-coordinate of the pinhole. After finding the x and y coordinates, you have found your pinhole. After, you must find the vertical asymptote of the equation by making the denominator equal to 0. Finally, you must find the horizontal asymptote by using what we learned. If the numerator is a lower degree, there's a horizontal asymptote at y equals 0. If there's the same degree, there's a horizontal asymptote at y is equal to a of the numerator over a of the denominator. And if there's a higher degree, you know that there's an oblique asymptote. A career that might answer this question is a teacher will need to understand this question and communicate it to their students in a proper manner so that everyone will understand. By being able to communicate the answer, you'll be an effective and good teacher.